Hey guys and girls, so in today's video we're going to be talking about metatables, and we're going to go through some of the meta methods, and once you've learned one meta method it's pretty easy to understand the other ones, and we're going to use this information to create our own vector2 data type. So let's first create a table, and let's set a metatable to this table. Now I'm going to demonstrate the index meta method. So if I create a loop for I equals 1 to 5 do, and if I print my table using the I value as a key, and I run the game, we can see it prints nil 5 times. And if I now set the second key to equal hello and run the game once again, we can now see it says nil, hello, and then nil a further 3 more times. Now to make the output a bit more easier to read, I'm going to print some dashes like so, and I'm now going to add the meta method index, so like this, and this function is going to give us the table and the key. And what I'm going to do is inside of this function I'm going to say print function called, and if I run the game now, we can see that for the values of nil the function is called, but for the value of hello the function was not called. Now it's possible to return a value back to whoever requested this key from the table, so instead of printing nil it can print any value we want. So for instance I could say return key to the power of 2, and if I play the game we can see that the function is called and it prints 1, then it prints hello, then the function is called again and it prints 9 and 16 and then 25. Now if I print the table and we run the game once again, we can see that even though it's printing these numbers do not exist inside of the table. And if I loop from 1 to 5 again and run the game, you can see that on the second time it loops, it calls the function again for each index that does not exist. But if we store the value inside of the table when this function is called, then the second time we loop for it, it should not need to call this function and should be able to get the value directly from the table. So to do this, I'm going to say t, and I'm going to use the key equals k to the power of 2, and if I run the game, we can see that the first time it loops, it calls the function, and if we look inside the table, we can see that the values have been added, and the second time we loop through the table, it no longer calls the function and just prints the values out instantly. Instead of using a function for the index meta method, we can also use a table. So to do this, I'm going to delete these lines here, and I'm going to make a new table at the very top called local index table equals this, and I'm going to delete this function and set the index to the index table. So what's going to happen now is when we attempt to print the value from my table, if the value is equal to nil, it's going to move on to the second table and print whatever's in this table. So if I add the key 2 equals by And if I also add another key to key 4 to equal by, and call this by 1 and by 2, and if I run the game, you can now see that it prints nil, then it prints hello, then it prints nil again, and it prints by 2, and then nil. So even though we set by 1 to key 2, because this table already has a key 2, this takes priority over this table. Now I'm going to show you the call meta method. So I have my table with a meta table, and I've set the meta table to the table. And now I'm going to add a function to the call meta method. And first it passes a table, which is this table here. And then it passes multiple arguments, which is defined by these 3 dots. We can convert these 3 dots to a table by doing this, and I'm storing this table in the args variable, and then I'm printing this with the args table, and now I can call my table like a function, and I can pass in any values like so. And if I run the game, we can see table called with args, and if we open the table, we can see it was called with cake and 23. And the add meta method returns the table and the value that we attempt to add to the table. So if I say my table dot value equals 20, and then I say t dot value plus equals v, and if I now print my table, and then I say my table plus equals 4, and then I attempt to print my table once again. Now if we run the game, we can see that the table first has a value of 20, and then the table is now equal to nil. And the reason that is happening is because even though we're adding to this table, we're not returning this table back to here, because you can see it's plus equals. So you need to say return t like this. And if we play the game once again, now we can see we have 2 tables. The first one had the value equal to 20, and the second one has a value that's equal to 24. Now let's use what we've learned to create a vector2 data type. So I'm first going to create a function called new, and this function is going to require a x and a y value, and it's going to return the table. So instead of the table being created here, we're going to create it inside, and we're also going to set the meta table like this inside of the function, and then we're going to return the table. It's also possible to have these 2 lines written differently. So instead of it being written like this, we can have it written like this. And now I'm going to store the x and y value inside of the table. So I'm going to say my table.x equals to x, and my table.y equals to y. And now let's add the magnitude variable to the table. So I'm going to say my table.magnitude equals math square root x times x plus y times y. Now let's create our custom vector2. So I'm going to say local vector2 equals new, and I'm going to pass in a x value of 23 and a y value of 36, and I'm going to print the magnitude. So print vector2 dot magnitude, and if I run the game, we can see it has a magnitude of 42. Now let's create the doc function for the vector2, But I'm first going to show you the incorrect way of doing the function, and then I'm going to tell you why it's incorrect, and then I'm going to be showing you the correct way of doing the function. So let's first create the dot function. And we're going to pass in the second vector 2. And now let's return the dot value. So return, and I'm going to say mytable.x times v.x plus mytable.y times v.y. Now if I create a second vector 2, and I'm going to call this one vector A and vector B, and I'm going to have this have slightly different values of 52 and 16, and then I'm going to say vector A dot, and I'm going to pass in vector B. And if we run the game, we can see it has a dot value of 1772. So the way we've created this function is not the most optimal way of creating a function for a data type. Because if I change this to this, and also print the dot function for the B vector, and run the game, we can see that the two functions are saved in different locations in memory, because these two numbers are not the same. So what this means is, every time we create a new vector 2, we're creating a brand new function that's consuming more memory. And if we have thousands of vector 2s in our game, that's consuming extra memory that we can optimize by sharing a single function for all the vector 2s. Recently, Roblox had an update where identical functions will be raw equal. So what that means is, if we can make this function identical for both vector A and vector B, they should both share the same function. And the reason they're not identical is because this function is using the myTable variable from outside of the function, and this variable is different for vector A and vector B. So to make them identical, what I'm going to do is say v1 and v2, and I'm going to get v1, v2, v1 and v2. So if we run the game once again, now we can see that the two functions have the exact same numbers, so they're both shared in memory. Now to call this function, I'm going to say print, and I'm going to say vector A dot, and we're first going to pass in vector 1, which is vector A, and then we're going to pass in the second vector, which is vector B, and if we run the game, we can see that we get the correct dot value. Now if we look at the dot function for the vector 2 of Roblox's data type, we can see that they do not require us to put in two vector 2s in the function, and only require us to put in the second vector 2. And the reason for that is, instead of using a dot, they're using a colon. So in Lua, there is a shorthand where if you use a colon instead of a dot, it will put this value here as the first argument into the function, so that you don't have to type it out yourself. So if I change this dot to a colon and delete the first value, now I can run the game, and you can see that it's still working and giving us the correct dot value. Lua also has a shorthand for writing functions. So instead of writing the function like this, I could write the function like this, and if I run the game, we can can see that the function is still working correctly. Lua also allows us to change this dot to a colon, so we can change this to this, and I can remove the first value, and I'm going to rename this to v, and now instead of using v1 we're going to use the self variable, and I'm going to change this to v, and if we run the game we can now see that the function is still working correctly. I personally do not like to write my functions this way. The way I would have done it would be to do like this, and I would have this called self and this called v, and I would call this self v self v. Before Roblox made this change, you may be wondering how we optimized our functions in our custom data types. So what we would have done was created another table like so, and we would have set this table as the index of this meta table, so like so, and instead of having the function created on every new my table, we would have had this function inside of this table over here. So I'm going to move this over here and change it to vector2, and now when we try to get the dot function from the vector, it would not find it in my table but use the meta table, and it would link to this table, and we would use this function which would be shared between every my table. So if we run the game again, we can see that the dot function is still working correctly. Another benefit of having this function saved in the vector2 table is that now it's impossible for this function to be saved in multiple locations in memory. It's also possible for the meta table to set itself as the index. So instead of having vector2, we could set the index to meta table and move this dot function into the meta table itself. And now we no longer need this table, so we have one less table. And if we run the game once again, we can see that the function is still working. Now let's add the plus operation. So I'm going to add the add meta method. So add equals function table value. So there are two ways we could do this. One way would be to just simply go t.x plus equals v.x and t.y plus equals v.y, and if I delete these and say vector a plus equals vector b, and then if I print vector a and print vector b and run the game, we can see that I forgot to return the t value, and that's why vector a is equal to nil. So let's make sure to return t, like so. And now we can see that the original value of 23 was increased by 52, which is now equal to 75, and the original value of 36 was increased by 16, so it's now 52, and while vector b has had no change done to it and still has the original values. You may also notice that once we've added vector b to vector a, that the magnitude is no longer correct, so we need to update the magnitude. So we can do this by going like this, and we can go like this, this, and like this. But if we look at Roblox's plus operation, we can see that they return a new vector 2. So to change our add function to work like Roblox's add function, I'm going to delete this and say return new t.x plus v.x, and I'm going to do the same for the y values. And you can see it can't find the new function because it hasn't been defined, so I'm going to move this new function to be here. And now if we run the game, we can see that the function has worked correctly and we have the correct magnitude and the correct x and y values. Now let's set up the equal operator. So if I set vector A to 1, 2 and vector B to 1, 2, and if I delete this and say vector A equals vector B, and if I run the game, we can see that it says that vector A is not equal to vector B, even though they both have the same x and y values. And the reason for this is, even though they have the same x and y value, they're not the same table. So to make it check the x and y value instead of checking the table, what we're going to do is say metatable dot underscore eq equals function table value, and I'm going to say if t.x is not equal to v.x, then return false. And I'm going to do the same for the y value. And finally, if they both are equal, then we're going to return true. So let's test the game once again. And we can see that it's now returning true. And if I change one of the values to 22 and run the game again, now it's returning false. And finally, let's do the toString meta method. So I'm going to say metatable.toString equals function, and this is going to pass us the table. And I'm going to return a string with the x and y value, and I'm only going to print the vector A value. And if I run the game, we can see that it now prints like this instead of printing the entire table. Thank you for watching the video, and if you have any questions, feel free to leave a comment down below.